In this in-depth tutorial, we will explore the exciting fusion of technology and music through 3D printing. By leveraging affordable and accessible 3D printers, you can now create your own musical instruments from scratch. Whether you're an experienced musician looking to innovate or a tech enthusiast curious about exploring sound design, this guide will show you step-by-step how to design, print, and assemble a functional musical instrument. We'll also cover the essentials, such as choosing the right materials, customizing the sound, and enhancing the instrument's performance. Selecting your instrument and materials. Begin by deciding which instrument you wish to create. String instruments like the ukulele, woodwind instruments such as the ocarina, or percussive instruments like a drum are all excellent options for 3D printing. Free designs are available on platforms like Thingiverse or MyMiniFactory. When selecting materials, consider their impact on sound quality. PLA is a common, easy-to-use filament, but materials like ABS or PETG can offer better durability and tonal properties, affecting resonance and sound depth. Designing the instrument. You can either modify existing designs or start from scratch using CAD software like Tinkercad, for beginners, or Fusion 360, for advanced users. Focus on precise measurements and the structural integrity of the instrument. For stringed instruments, pay close attention to neck length and bridge placement to ensure proper tuning. Woodwind instruments will require accurate calculations for hole placement to generate the correct notes. Slicing and printing. Once the design is ready, use slicing software like Cura to prepare your STL file for printing. Larger instruments may need to be printed in multiple sections due to the size limitations of home 3D printers. Make sure to optimize your printer settings based on your filament choice. Layer height, infill, and print speed will all affect the instrument's durability and tonal quality. Assembling the instrument. After the printing is complete, remove any supports and sand the edges for a smooth finish. For stringed instruments, add the necessary hardware, such as strings and tuners, and securely assemble the body parts. If you're building a woodwind instrument, pay attention to airtight seals around the joints to avoid leaks that could impact sound production. Most 3D printed instruments will require manual adjustments and tuning to ensure optimal sound quality. Tuning and testing. Once assembled, tune your instrument using an app or tuner. Stringed instruments will need proper tension, and you may need to adjust the bridge and neck alignment. Test the sound, and feel free to experiment with different materials and designs. For woodwind instruments, use different finger placements to test the accuracy of each note. Performance and future enhancements. Play the instrument to evaluate its performance. 3D printed instruments often provide unique acoustics, offering fresh sounds not possible with traditional materials. Experiment with different design elements, and feel free to modify parts of the instrument in future prints. You can also create multiple versions using varied filaments to test their effects on the sound. Thanks for joining us on this creative journey into 3D printed musical instruments. We hope you've gained a new appreciation for how technology can reshape music. Don't forget to subscribe to CyberTheo for more tech tutorials like this one. Let us know in the comments which instrument you'd like to 3D print next, and feel free to share your own designs and experiences. Hit that like button and share this video with fellow creators and musicians.